So, is it visible, my screen? Is it visible?
Yes, ma'am.
Okay. So we have discussed yesterday. We have discussed about the public mode of inheritance. That means whenever any existing class is there, which is known as the base class, and if we want to create some new class by inheriting all the properties, all or some of the properties of the base class, that is known as inheritance, and the newly created class is known as the derived class. So we have seen if we create a new class with public mode of inheritance, what are the different features or how much is inherited. So today we will introduce a new access specifier and we'll see the protected mode of inheritance a little bit. Okay, and we'll discuss about protected access specifier. So till now, do you know what is protected access specifier from the introductory class or by the discussions? What is your idea about protected access specifier? Yes.
Ma'am, if a derived class wants to inherit some member from the base class, but don't want it to be like available to anything outside those classes.
Yeah, that is partly true. So let us start from this point only. Okay, let us consider one example where we'll see two different views. That is, after inheriting the normal public and private, say normal public members that we know, but about the private members, what are the views actually? Let us see this with the example. So we now are going to discuss this blue area, that is the derived class can access protected data members of base class. So this point we are going to elaborate today. So let us see. So let us consider this example. Here I have done. I have considered two views. One view of the members for the base class, okay, from the global function, that is we know that the global function, that means main, from main, and one view from the derived class. Derived class function. Okay, so let me explain the example first. So here what I have done, here I have taken one base class called B and two data members, one private data member, that is B1, and one public data members, that is B2. Okay, and whatever the rules we have discussed, that the private members, they are not accessible globally, and the private data members can be inherited but cannot be accessed. Okay, so these are the properties of private data members. So we will now study the view of the private data members, that means how much it can be accessed, whether it can be accessed from global functions or whether it can be accessed from the derived class function. Okay, so we will compare these two views. So first view is from global function. So we all know that from main it is not possible to access B1. Okay, because B1 is a private data member. So here this is the base class definition, and I have created one derived class definition. So this is the derived class definition. So derived class definition, we have inherited this as public B. Okay, so for simplicity we have kept the derivation technique as public. We will later we will discuss if this in place of public, if we write down private or if we write down protected, what will happen, that we'll discuss later. Let us first understand the protected access specifier and its use, and then we will gradually come to that point. Okay, so now what we have done here, the class D have inherited B scope resolution B1 and B.B2. These two things it has inherited, but we know that even if it is inherited, the private members, they are not accessible. Okay, now it is having its own data member, that is D1. Okay, and one member function called this, and this is the function definition. So in the member function, what we have done, we have just tried to call this B1, B2 and D1. Okay, now this view, this particular view, belongs to this function. Okay, this function. So what happened here, if even if we have derived this thing, this class D from B, we are getting all these members, but it is not accessible from the derived class. B1 is not accessible from the derived class. However, B2 is a private data member, public data member. So B2 is accessible and D1 is its own data member. So it is always accessible. Okay. Now this is the view for the derived class. Now let us consider the view for the main function. So this one is actually the view for the main function. So in main function, I have created two objects, one for the base class and one for the derived class. And I have tried to use B, that means base class object, to access B1 and B2. For B1, it will not work because we know that B1 is not accessed globally. Okay, because it is a private, and for B2 it is a public data member, and public data members can be accessed from anywhere, so this works fine. Similarly, if I have tried to access the same data members from D, the object D, small d, then also B1 is created problem because it cannot be accessed globally, and B2 and D1 is accessed fine. Now my point is, even if we are having this inheritance, we are deriving all the all of these things we are inheriting. Again, from the local function, we are not able to access these private data members. Okay, so B1 is always remains inaccessible, whether it is global accessed from global or whether it is accessed from derived class function. So there is no extra privilege for the derived class function in terms of access to base class members with private access specifier. Okay, so the objective is to access the thing. Objective is to access the different data members. Okay, but here this is okay, quite okay, because for data protection we are not able to access, but we are expecting that there may be that this local function, this public function may access the private data members, but then also it is not having the access. Okay, so both of these views don't have access for B1. Okay, so the for solving this, or to give a little bit of access, then comes the idea of the protected access specifiers. Okay, so what the protected access specifier does, that I have shown in with a little bit modification with the same example. Okay, so the example was previously B1 is private, B2 is public, and I have included one more member, that is B3, which is known as protected. Okay, now the protected is having this facility that the protected access specifier, means members that are defined with protected access specifiers, they are not accessible globally. That is fine. Okay, because we want to protect the data. Okay, so not accessible globally, but it can be accessible within derived class. So with the same example, when I have created the derived class with the function, with this one is the derived class data member, and with this function again I have tried to access all the derived data members. Okay, so B1, B2 and B3, this is derived from class B, and D1 is its own local data member. So this will be accessed, B2 will be accessed, that we know. This also will be accessed if it is base protected. Okay, that means if it is a protected member, it can be accessed from within the derived class function. So previously there is no access, even if this private data members B1 and this B1 is not accessed. But here B1 and B3, they cannot be accessed from global function, that is from main. Okay, if we want to access with B all these data members and with D all these data members, this B1 will give error and B3 and B1 both will give error, because they will work like, means from global function they cannot be accessed. Okay, the protected and private, they act like in a similar manner, they are not accessed. Okay, whether it is private or protected, but the local members always, public members, they can always be accessed. Similarly, for if I use object D to access B1, B2, B3 and D1, these two will work fine, but these two won't work. These two won't work. Okay, so global view, we are protecting B1 and B3 from the global view. That is fine because we want to protect the object, but B3 is, irrespective of this, B3 is here, it is very much accessible. That means from within the immediate derived class. So one rule we can draw from here, that if a member is protected in the base class, that can be inherited and can be accessed from the immediately derived class. Okay, we can say that. So this is the rule related to protected access specifier. That's why yesterday I told that it is having a little bit of restriction on the public data members and little bit relaxation with respect to the private data members. So are you getting my point? Is this clear?
Ma'am,
Yes,
Yeah.
ma'am.
Yeah.
can we access protected member of base class in its drive class directly or by its member function in its drive class?
You can use it directly. You can use it directly. Directly means here I have used this member function. How we will use the member directly? You tell me. Within some function, na? Or
Yes.
what we will do in public and private within class? How we will access? Without any function, can you access?
No, ma'am.
So that is your answer. So you can ask one more question. That is, if say this is single level of inheritance. Okay. So this is the base class and this is the derived class. Now this is fine. Only one level of inheritance is there. But if you have this kind of thing, say base D1, D2. So will it work for the protected data members, or how it will work? The rules remain same. That means if B is having some protected data member, it will be accessed by D1. It can be accessed from D1. D1 means D1 inherits the protected member of B. Say there is a protected member that is inherited by D1, and D1 can access it from within D1, the view of D1. Similarly, the same member, if it is inherited to D2, if it is coming to D2, D2 can also access it, but it will be level wise. Okay. So this may be another question. Okay. So always remember the if you are having some protected data member and if some new class is created by inheriting it, it will be just the immediately derived class which can access it. The same manner will continue for all the levels. Say if there are 8, 9 levels, the same rule will continue. Okay. So you can modify this program and can see how they are acting. Okay. So is it clear? You understand this thing?
Yes, ma'am. Now clear.
Yeah. So all these things I have discussed here. The protected access specifiers, they provide extra privilege for the derived class functions in terms of allowing them access to such members which are otherwise inaccessible from global functions. So this is actually the advantage of using protected data members. Okay. So base class protected members acts like public members within its derived class functions. And base class protected members, they act like private members from the global function. So this is the global view and this is the derived function view. That means the local view. Okay, so immediately derived class can access, but from global function, it will act like a private data member. Okay, so next, let us see some overriding and overloading of functions during class derivation. So this we have discussed with the very beginning, that if there is a base class called classroom and there is a class called smart classroom, where we have added some of the methods. So this take lecture method, it is a overridden method because it is having similar signature. That means the name of the function name of the method and the number of arguments, type of arguments, all are same, only the body is different. Okay, so that is known as function overriding. And we know what is function overloading. Overloading means the same thing playing multiple roles. So same function but differ in number of arguments, terms of argument, and it can add some new functions. Okay, so we will discuss these two things, overriding and overloading. We'll consider one or two examples for this, and we'll see how they act when we do this type of overriding or overloading in our inheritance, how they act. Okay, so I have defined it that derived class inherits all member functions to base class. Derived class may override a inherited function of base class by redefining it with the same signature, and derived class may overload a inherited function of base class by redefine it with the same name but with different signature. Okay, and it can add new member functions. So let us take one example and see how it works. Okay, so I have taken one example. The left side I have written, and I have done a little bit modification in the right side to show how overriding and overloading is done. Okay, so for simplicity, I have taken this base class and two functions, base functions. I have not written their body, just I have written their signature. Okay, F and G. And for class D, that is the derived class, I have not written any member, just it inherits this B colon B scope F int and this D. So this F and G is inherited here. Okay, in the derived class. And normally we try to access all the member function, all the data members by using the base class object or by using the derived class object. So B is a base class object and D is the derived class object. So here I have tried to access the F and G with the base class object. So this the type matches because this is base, this is also base, so this matches. So it calls this B dot F and B dot G, they call this B the function that is written in B. Okay, so they call the function that is written in B. Okay, so they call the function that is written in B. Okay, now I have tried to call the derived class, you tried to call F and G with the derived class object. Okay, now this derived class object is having one copy of this F and G. So they will also call this B copy of this, what is derived from B. They will also call the same function. So this one is very simple because D the object of derived class, they don't have any other local function. So there is no ambiguity. Here there is no other local function, only these two functions are inherited coming here, and these are whatever be the object, if it is the similar type of object, then also it is taking it is accessing F and G of B, and if it is the derived class object, then also it is having this copy and this copy is accessed. So this is fine. Okay, there is no ambiguity. Now what I have done in the next example, I have tried to write down similar kind of functions in the derived class, so that it will create some ambiguity to the compiler that which one to use. Okay, so what I have done here, I have created three functions. One, this F with int, F with float, and another new function that is H with int. Okay, so what happens if I have F int, F float? So this F int is also inherited here. If F int is also inherited, so this derived class D, it is having one F int that is from B, one F int that is its own, one F float, one function float having argument float that is its own, and this function int that is its own. Okay. Now the confusion is, if you are having, I told that with same signature, if you are having same signature, one is from base class and one is from derived class. So which one is to use? Now here we have created base object and derived object, and we are trying to access this f and g with base. So this works fine because b and f and g, the type matches, and they will call these two. So b dot f1 and b dot g2, they will call these two. This is fine. There is no ambiguity. Now the ambiguity comes if I write down this one, f d dot f3. Now this one will see which one to match. This one is matching, this one is also matching, because it is having two copies. One copy inherited from B and another copy that is its own. So which one to use? So if this kind of situation occurs, then the compiler always considers a local copy, and d.f int, it overrides this b.f int. That means if that base derived class is having its local copy which is matching with the call, with the function call, then the binding will be with the local class. Okay, so this one will override the base class function that is having same signature. So here overriding happens. Okay, and for the next call, that is df 3.9, so it is matching with the float. Okay, so it is matching with the float. Also we are having this one f dot int, so that there is a simple overloading. Because overloading, we know that the signature, the name will be same, but the number of arguments, they can differ. So it matches with the float. So it will call this f dot float. Okay. So here, even if we are having f another function, but it is not matching. One f int function is there which is inherited from B, but it is not matching because this here we are passing 3.9. Okay. So next is this. So this f float overloads this b dot f int, and next is d dot g4. So for this derived class object, g4 is not redefined. Here f int is redefined, f float is redefined, but g is not redefined. It is d is having another copy of this g int from B. It is inherited G int from B, it is inherited F int from B. So this, what it's inherit, this will call this G int. That's why I've written calls B dot B colon G int. Okay. And then the last one is its own data type, its own type function, age, its local function. So it will call with this one. Okay. So is it clear, this example? You understand this example? The main idea is, if we are having the base class and the derived class, and if we are having similar functions, similar signature, similar functions with different signature in the derived class, then we will see which one will override and which one will overload. Okay, so always the local functions will be given the preference if it matches and if some kind of ambiguity occurs. So this is the rule. So is it clear? You understand this thing?
Yes, ma'am.
Okay. One more example I have added here. Just see this one. I think all of you know what is static data members and static member functions. So I have just created one base class with this public int x and one static variable s and one static member function fstat. Okay, so this fstat will just write down output this b fstat because it belongs to b. Okay, and it will just print the value of s. And we have defined the value of s, so we know that static data members need to be defined outside the class, and this is the definition, that is return type, the class name and the scope, and the static variable name and the constant that we are initializing it. Okay, so I have just used 10. We have stored 10 to S. Okay. And what I have done, I have not created any new data member in the derived class D. It just inherits this X, this S, and this function. Okay. Now we have created the base class object B and derived class object D, and I have tried to access all of them. So B.X, it works fine because it is the private public data member B.X. And B B colon B scope resolution S and B scope resolution F stat both will work. Okay, because they are the static functions and we know that how to call them from main. Okay, so it will work. So this gives 10, this also gives 10. And for D, this D.X also work because D is having its own copy that is inherited from B. Okay, so X is public, it is inherited and it works fine. Similarly for S and F stat, it works fine. Okay, so for S, it is not having any data member. So this S, it will print this 10. Now D colon F stat, this calls the inherited one that is inherited from there. Okay, so this is public, so it is inherited. Okay, so this F stat function belongs to this B, so it will print this one. Okay, B F stat, this one. Fine. Next, what we have done here, we have written the same base class with the same function with this data static data member and static member function. But what I have done, I have tried to create the overriding effect. I have used the same static member function name and same signature here. Just the difference is, see, the body. Okay, its body is printing B F stat and value of S, and this is printing D F stat and value of S. Okay, and I have not changed the value of S. Value of S is 10. Okay, now see what happens. Here also the same rule follows. So it is overridden. Okay, so this one is overridden. So if you have the local copy, that will be having similar signature, so that will be given preference. So this part is fine because all this thing will print B F stat and 10. But here what happened, whenever we use D dot X and D dot S, okay, it prints 10. But when we call D dot F stat, this function actually belongs to this one. It calls this particular thing. That's why this one is printed F stat and 10. 10 is for S. It is printed. It is not printing. Previously it is printing B F stat. But now it is printing D F stat. So the point is, even if we are having the similar function with same signature, okay, it will be overridden. So now you understand, whenever you are inheriting, we need to remember which one is overriding and which one is overloading. I think it is clear. Okay. Any doubt till now? Hello? Hello?
Yes, ma'am.
Okay. 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 So next we are going to discuss about the construction and destruction part. Okay. So we we have seen that how member function acts in inheritance. We have seen how access specifier works in inheritance, different type of access specifiers and their related rules. Now we are considering about the construction and destruction. So like the normal functions, like the normal classes, normal objects, this inherited class also, the derived class may also have constructor. Okay. So during construction, a derived class object, its constructor first calls the base class constructor to construct the base class instance within the derived object. Okay, so this is a very long sentence. I'm telling it in a simple way that when we are having one base class B and some constructor here, within B, and then we are having some base class, a derived class D, and D is having some constructor. Okay, so it will be the responsibility of these constructor, because we are passing some arguments in the constructor. So it will be responsibility of the constructor of the derived class to call this one, to construct this one, then it will be called. Okay. So whenever you call any, you create any derived class, the responsibility of the derived class constructor is to first call the base class constructor, do all the calculations, do all the construction part, initialization part, then it will come to the base one. Okay, and it will go on. That means if you have any class like this, say C, that inherits public B, okay, and C is having some constructor, then also C is calling D, and then it will check which class is it is inheriting, it will call its base class. Okay, so first B will be constructed, then D, then C. Okay, so this is the rule. Okay, so the rule is just the reverse, like the destruction. So whatever is constructed first, last, that will be destructed last. Okay, so let us see with some examples. Okay, with one examples, and I have there are certain rules that I have listed here. So the rules are: if the base class constructor takes no argument, then it is not required to the derived class to have constructor. Okay, and if the base class constructor takes argument, then it is mandatory for the derived class to have constructor with one or more arguments, and they passes the argument to the base class constructor. Okay, so here I have written one derived class constructor syntax for one derived class constructor. So it will be the derived constructor, and one argument list will be passed. After that, some colon, and then each of the argument list will be sent to a base class. Okay, base 1, base 2, base 3. So these argument lists are sent. So we know that initializer list, I think sir has told you, initializer list. You know this one, na?
Yes, ma'am.
So this is the initializer list. Okay, so the rule is that if we are having a base class constructor, if you are having derived class constructor, then the derived class will be taking all the arguments, and it will pass these arguments to the base class, and then the body of the default constructor. Okay, so next let us see with a very small example. Okay, so let us justify the output with this example. So I have written both the rules here that was written in the last slide. Okay, for better understanding. So what I have done, I have tried to show you when the constructor is called and when the destructor is called by giving this body. Just see out this B when constructor is called, and the tilde D and tilde B when the destructor is called. Okay, so this is for the base class, and next I have created one more class C. Okay, so this is the constructor and destructor for C, and now you see I have created one class D from public B. Till now we have used the access specifier mode, the mode of inheritance as public. Okay, that is for simplicity. After that we will discuss this thing. Okay, I don't think today I'll have time, but in the next class I'll discuss what happens if I provide here protected or private. Okay, so for simplicity I have taken public. So now this one is inheriting B, and inside B C is having one object C1. Okay, and after that it's definition of this constructor and destructor, and I have created three objects B, C and D. Okay, so for B, whenever we are creating B, so this B will be called, this is fine. For this one, this is the output, because this is the base class. Now whenever I call C, this will be calling C, because C is another class. B is a separate class, C is a separate class, two different class. But what happened with D? In D, we have inherited B and we have created one object of C. Okay, so it is the responsibility of D to call all the constructors, to construct all the constructor that from the base class as well as from the other class, and then to call its constructor. Okay, so what D will do whenever we create this line, whenever object D is created, it will not directly call its constructor. What it will do, it will first see that it is inherited from whom. It is inherited from B. So it will create, so this call create first calls the constructor of B. Next it comes inside and see this one. So it calls, after this it calls C, creates the constructor C, because for with this object creation we know that whenever we create object, constructors are called implicitly, automatically. So C, for C it is called, and after creating all these constructor, all the calling all this constructor, D will be calling its own constructor, so D. And the destruction, after this we go out, so the destructor will be called automatically, and the destruction is just this is this order, and just the reverse order the destructor is destructed. It means tilde D, then tilde C, B, C, B. Whatever in the order they have created, they have destructed in the same order. So you understand this thing? So first the constructor of the base class will be created. Then if there is any other class, any other object is created inside, then that will be created, and after that the derived class constructor will be created. So here I have not used any argument. For simplicity, I have not used any argument, any parameterized constructor, just I have used normal constructors. And I tried to show you with the output line. So is it okay? You understand this thing? Huh? Yes, yes. Hello? Hello? I'm not getting your query.
His voice is lagging.
Please mute your microphone if it is irrelevant to this class. Please mute your microphone. Okay. Let us continue with one more example that is having parameterized constructor. Okay. So here I have shown you one example where I have taken all the members. You see, all type of members: protected, public, and private. So B1 is private, B2 is protected, and here one function, this is the constructor. Okay, so in constructor what I have done, can you tell me what is this? This is a default argument. Okay, I have taken one default value for this argument. Okay, so B is 0 I have taken. So just recall the default argument. Okay, we can take any value for the default argument, we can pass, and then whenever we call the function, we can pass the actual argument, we'd get replaced by the default argument. Okay, and this one is the initializer list, constructor initializer list. So what we have done here, we have taken this value B and we are passing this value to B1. We are initializing B1 and B2 with this value B. Okay, so here I have taken B, default value for B is 0, but you can have any other value. Okay, later. And inside this constructor, one line I have given so that I can say that which constructor is called. That's why I have written this thing and the value of B1 and B2. Okay. So I have not listed down the output. In the next slide, I have listed down the output. Let us first see the memory map and what happens. So these three things, I have created three objects, X, Y, and Z. Okay, and these are the values. Okay, so how this, what are the, why these values are there, that we are going to discuss in this particular example. Okay, so this class D, now this class D is created. This is the definition of class D. It is derived from B. Okay, and it inherits B1 as private. We know that if something is private, that can be inherited but cannot be accessed. And if it is protected, that can be accessed within the immediately derived class. Okay, so we need to remember all the rules. Okay, and its own data member, that is public D1. Okay, now here I have listed down two constructors. You see, this is constructor 1 and this is constructor 2. So for the first constructor, I have taken two variables, int b and int d. And what I am doing, I'm passing this b to capital B. That means with this b, I am constructing the base constructor. And the later one, I am just giving the value to D1. D1 is its local data member. It's public data member. Okay. So these two things. And this constructor is called, that is for constructor for D with two arguments. That's why this is the output and the value of B1, B2 and D1. Okay. So next is another constructor that we are having only one argument. Only one argument. Okay. So we have passed this argument to initialize D1. This D to initialize D1. D1 is its data member. There we have not passed any value for constructing the base class constructor. So this base class constructor, here we are providing the value. But for this one, we are not providing any value. So what it will consider? The base class constructor will be constructed with the default argument. That's why we have provided the default argument as b equals to 0. Okay, now you understand this thing? The same thing I have used here, just here it is two argument and here it is printing this one. Whenever this particular constructor is called, it is printing d int and value of b1, b2 and d1. Okay, now I just put nothing here, some dot dot dot, and this is how we are calling. So for x, bx, so for x, what will be the value of b1 and b2? Which constructor will be called? You tell me. For x. For x, what will be the output? You tell me.
The B constructor will be called.
This will be called. This will be called. And the value of B1, B2 is 5, 5. That's why this is written 5 and 5 because 5 is passed. And B is by default it is 0 and it replaced by 5. So B1 and B2 both will be initialized with 5. So B is 5 and 5. Is it clear? You understand this thing?
Yes, ma'am.
Yes, ma'am.
Okay. Yeah. So next is we are creating one object for D, that is Y 6 and 7. So Y 6 and 7. So for which one this one is matching? Which constructor will be called? D is having two constructor. Say this is 1 and this is 2. Which one is called? Number 1. So for this one, what will be the output? Can you tell me what will be the output? Recall the idea of constructing derived class constructor. So as per our rule,
6, 6, 7.
Exactly 6, 6, 7. Why 6, 6, 7? Because this 6 is this one. This B is 6 and this D is 7. So 6 is sent to construct this B. Now, whenever we send something to construct B, the constructor of B will be called, this one will be called, and it is constructing B1 and B2 with 6. So the value of this will print, what it will print? It will print value of B1, B2 as 6, 6, and then it will initialize D1 as 7 because this 7 is sent, this is the second argument sent to D. So 6, 6, 7 will be print. That's why it is written B1 and B2 is 6, 6 and 7. In the similar manner, whenever we call with only one argument, we are not passing any argument for B, constructor B. So it will take the default value, that is 0, 0, and D1 is initialized with 8. Okay. So this is the output. With the same example, this is the output. So let us see what will be the output for B. For B, this is B int 5, 5. Next, this one, for this 6, it will call to this B int 6, 6. So this line is for this one. And then after creation of B, this one will be called. So this line calls this 2. Are you getting my point? Because it is the responsibility of the derived class constructor to construct the base class. Right? Is it okay?
Yes, ma'am.
Next, for this Z, again, it will construct B and then it will construct D. So this is 0, 0 and this is 0, 0, 8. B dot int is called and D int is called here and then 0, 0. And just in the reverse order, all are destructed because after this this is end of the program. Okay. So base portion of a derived object is constructed first, followed by its derived portion. Okay. The derived portion is destroyed first, followed by the corresponding base portion. So these are the two rules that we can derive from this example. So you got my point? Is there any other confusion? You can tell me. Is it okay? Yes?
Yes, ma'am.
Yes, ma'am.
Okay, so today up to this. Okay, so today up to this, and tomorrow we don't have class. Thursday again, I'll try to cover this part. Okay. So let's see how much I can complete before your exam, but I'll try to complete inheritance. Okay. Okay, just tell me what is done in the class yesterday's class. Sir has told you friend function.
Yes, ma'am.
And introduction to overloading.
Yes, ma'am.
Operator overloading.
Yes, ma'am.
Okay. Then we will complete this thing by this week. Okay. And after that, exam will be there. And next week, I think next week you're having exam. Next week, 10th, na?
Yes, ma'am.
Okay, then we'll have exam, and after exam, then you'll come back and we'll have offline class. Okay. So till now, if you have any query, you can ask me. Otherwise, you can leave. I think you also have the next class. Yes.
Thank you, ma'am.
Anything okay? It seems no query is there, but you go through the slides. Okay, I'll be sending the slides by today. You go through the slides. If you find anything that you are not understanding, you tell me in the class. Okay. I have tried to explain the things with different examples, but there are so many examples in books also. You also try those examples. Okay. And these examples you can just check from the slide, and you can just do some modification and see what are the different types of result it is giving. Okay. Okay, so let's leave today. Let us meet on Thursday. Okay.